It's 6:38. Meeting is called to order. Open forum for any non-agenda items that members would like to put on, and open time for the public. Seeing no public, we'll move on to approval of the meeting minutes of August 13th. Did people get a chance to look over those? Mm-hmm. Okay. Any questions, issues, changes? Is there a move to approve?
I move to approve.
Is there a second?
Second.
Okay, all in favor? Aye.
Aye.
Okay, Marina Village levy study.
So if it's all right with you, we're going to adjust the agenda slightly. Rachel Kamen will be here shortly.
Okay.
But I thought in the meantime, maybe we'd jump ahead to Golden Hine tidal flood at Ebb Passage, if that's all right with you.
Yeah.
Okay. And just want to, we do have a packed agenda today, so just want to kind of give a little reminder. We've set aside what we think is the appropriate amount of time for each item, just to keep us on track. So that's there on the right side of each title. So we'll start by talking about Golden Hine tidal flooding at Ebb Passage. We did speak at our last meeting a little bit about this, so we're going to do a little review and then also dive into some new exhibits and discussion items. So as a reminder, here's the project location, Mariners Cove, at Ebb Tide, and Golden Hine. We do have a bunch of elevation sample data, and if you remember from the last meeting, we kind of spent a little time showing the different elevations, in particular at the intersection of Ebb Tide. It tends to be a low spot. Here it is zoomed in a bit, and you can see as you go up and down on the screen, it tends to rise in elevation. So generally, it's flooding there because it's got a sag in the road relative to the other locations. So this is kind of the existing condition that we're seeing at high tides. As the water rises, it's getting high enough that it's passing through the sides of the houses, and possibly also could be coming in subsurface. And what it's doing is collecting on the roadway and creating a pond there. Here's a current overview of our project. We're at 90% design plans, and the engineer's estimate is currently at $1.8 million. And part of the project is the pump station improvements there at the intersection. There's also, originally I think there was also the idea to put in a bunch of slotted drain. So it's possible there may be some opportunities to reduce funding and reduce some of the scope by reducing the slotted drain if that's desired, but as it stands at 90% design, it's currently shown in the plans, and as a result, the cost is $1.8 million. So, as you can see here, there's a light gray line kind of toward the middle part of the screen. Do we have a pointer? Does that one work? Okay. There you go. Sorry. So here, this is the existing gravity system, and it all flows out to a check valve, or it's kind of the duckbill type. And the design concept is to reroute the piping and have it go through a pump system and then reconnect to the existing pipe that goes out. And we wanted to kind of spend a little more time and go into some of the high tide, low tide scenarios and see the benefit of the pump station. And so I'll kind of go into that next. So we compared, the gravity system that's there now compared to a pump station system, and kind of did a very kind of basic overview of how it's going to perform in the various tide conditions. So here in the low tide, both systems work. All the water can flow downhill and out into the marsh, and so it's, good thing because both are working. Go ahead.
And does everyone feel oriented? Do you know what everything means here? So this would be, if I can get this, it almost wants to work. Did yours work, RJ?
Oh.
So this would be the crown of the road, right? And then this is the curb and gutter. This is more or less the elevation of the pump, the current pump station, which is a sanitary district pump station. And this is basically kind of the face of the edge of land interfacing with the bay. And so then RJ kind of has these little keys up here that explain, whether the gravity is working or the pump station's working. So, this is just kind of a semblance of what that looks like. I just want to make sure everybody understood what we were drawing here.
So yeah, you can see in the low tide condition, both systems work. I'm sure with the pump station there'd be a time savings of it flushing water out quicker, but nonetheless they both do work. This is the intermediate tide condition, and so this is one where the pumps do work and the gravity does not because the valve is shut because it's being kind of held closed by the tide being higher than the pipe on the outfall. So there's definitely a benefit there of the pump system. Now this one is the high tide condition, and because we're looking at a large investment, it's worth understanding that this may not or will not fix the problem in all conditions, because essentially the water is so high that it's kind of pumping in circles. It's taking it from the roadway out to the marsh, but it's returning right back. So, we don't, without doing a very detailed analysis, I think there would be some time savings in how long the road is inundated with the pump system. Yeah. But I think for expectations and the investment we're putting in, I think it's worth noting that it still will flood the road system as a standalone pump station install. So this is kind of a fourth scenario, and just something we wanted to talk to you about. I think there's been discussions about a possible barrier on that side of the subdivision, and I think that's something we're going to look at as part of the climate adaptation program or the plan. But if there's a solution that's able to prevent the water from flowing into the road, that in combination with the pump station would work in all scenarios. So it kind of brings the discussion to, timeliness of these projects and how best to plan them in the timeline of the various capital improvements we recommend as staff and as the flood control board.
Any questions?
So I wasn't here at the last meeting, but I saw in the notes that Bob had mentioned that there's that scenario where everything's working is contingent on two things. One is on the check valve working properly and not letting water back up through the storm drain, and we can test that or check it or replace it. And the other is that there's no underground groundwater flow that's coming up, which is a lot harder to test. So I don't know if there's more we can do to try to figure out if that's actually happening. It sounds like if you guys check and trust the check valve and know that that's not the way water's getting in, and then if you see water coming up in the street before it goes overland, you know that there's a subterranean pathway of some kind, and at least you'll know that even with this barrier, you're still going to get that flow. I don't know if that's something we could fix or not, but at least we'll know at that point that it's still happening.
Yeah, I would have the same concern on that too. The check valve is not working now because at high tide or modest tides, it comes right up through there. I thought that there was they tried to put a check valve inboard in the catch basin. Do you think that it was on the outboard side?
Well, you have, I know on the outboard they have the duckbill check valve.
Okay.
Whether they have a second one, we'd have to look into that.
Oh, yeah. In light of what Nate is saying, what I think would be good is if Public Works could observe that catch basin as the high tides are coming in, just to see what's going on in that catch basin. It's settled so much that I suspect the catch basin is broken up, and that, water's getting in all around it, or the connections aren't good with the pipes that are there, and that the catch basin may have to get rebuilt as part of this project.
I think one thing we did witness several months ago is that there is water that is seeping in, whether it's through a faulty check valve or just people's French drains on their property, or even we saw one sewer lateral that could have been contributing, but there's likely some penetration from a number of locations, or gaps in pipes and whatnot.
Including the soil structure. I mean, that could be very pervious soil. So well, I know that RJ and I have some plans for January. I know both at around Christmas time and Martin Luther King. As public employees, we're fortunate enough to have those times off, but we are going to come in around that time and kind of observe some of the king tides there and see if we can see water filling into the catch basin prior to it breaching overland and coming in between the homes and the pump station. So we have some observational work to do. I think that one thing the department has committed to is getting the plans 100% complete. That's something we have budget for. But in terms of putting it out to bid, that's probably something that we would hold off until the climate adaptation plan is done, and kind of takes a holistic approach at all of the town's sea level rise needs.
I have a question. I don't know if this is on.
Yeah.
So is that on? Can you hear me?
Okay.
Do you know if, similar to the French drain, if the people's homes right around there have some pumps that discharge into the street?
Some do, yeah.
Yeah.
Just about everyone in that area has elevated their home. I was out there today and I spoke with a homeowner, and yeah, I know certainly in that neighborhood a lot of people are using the sump pumps, but that a lot of that is groundwater, tidal water. I don't know that it's contributing that much to street flooding. I think the street flooding that we're getting would either be from heavy rains or tides or a combination thereof.
Okay.
Yeah, most of the homes that are on the creek that have sump pumps have the sump pumps that evacuate into the creek.
You would hope.
Yeah,
you would hope.
So
Yeah.
I haven't really noticed those that come into the street at that point. I think possibly the idea of putting the pump in, and if we're able to have a check valve that'll work and the street won't get flooded from the catch basin, the neighbors may be able to do some projects that will help prevent it from coming overland. And we are going to need the pump in the long run, so it may be appropriate to plan for it with this. I also think your idea of looking upstream, particularly to the north, where it's higher elevation, I don't think there's significant ponding in that area, and I think the slot drains really need to be more just immediately around the catch basins to stop the ponding, especially to the south on Golden High. Any other thoughts?
No, I'll wait for the next. I assume my questions about the barrier along all properties will be covered by the climate adaptation plan.
Okay.
Okay.
Yeah, so I think what you're outlining is a good plan. Do some observation, see what the status of the check valve, see what the status of the catch basin is, and then decide, what's going to be the best approach on that. But I would think that we could save some money by not putting in slot drains in the whole watershed. Okay. What do you want to go to for
All right.
next
I
item?
think we can go down the rest of the items until our presenter comes. So we can move on to climate adaptation.
Okay, so thank you, RJ, Chair Bundy, members of the board. I just wanted to give you an update on where we are with our climate adaptation plan. We put out an RFP, thanks to RJ. He put in a lot of work getting that ready, and we received some responses, and the best of the responsive teams were interviewed, I think it was a week ago today. And so we sat down with them and went through what their vision was for the town's climate adaptation plan. And the two firms that we sat with did a pretty good job. I think they were both very close in terms of their ability to provide the town services that we're looking for. And so we're ready to be in discussions with the top firm in terms of getting them into contract and having them provide about 18 months of planning, community outreach, and really a deep dive into what the town expects over the long term in terms of the major climate impacts that we're facing here in Northern California on the Bay. The major ones, obviously, sea level rise, drought, wildfire. Those would be the top three in my mind. And then, of course, some other ones in terms of, air quality. It's a Caltrans grant, so we're going to have some focus on the transportation system. And I think both firms did a good job of presenting that they understand what our town's needs are. So we do have a little bit of paperwork to do with Caltrans in terms of our award requirements. We plan on the December 18th meeting, taking the award consultant contract to the council for approval and award. And then we hope to kick off the project early next year. And the one thing that I wanted to let you all know about is that we do plan on 3 community workshops and multiple meetings with the council, the planning commission, and the flood board. And so I would like for one of your meetings in 2019 to be fully dedicated to the climate adaptation plan, going over what we've come up with so far, what your expertise can lend to the matter. I just think that this board is going to have a lot of useful input, and of course we invite you all to attend any of the other community workshops that we have. Bob has, Chair Bundy has read a few emails of mine, and I'll just repeat some of those key points to the whole board since you're all here. And that is that when it comes to major capital investments, one of the things we're looking for out of this adaptation plan is recommendations on what independent consultant, third party believes is best for the town's long-term vision. So what type of investments should we make on the capital side? Where should they go? What components of the community stand to benefit? What are our most important resources? I certainly think that our economic generators, some of our residential neighborhoods, and our transportation infrastructure, things like US 101, Paradise Drive, Redwood Highway, all highly subject to flooding and sea level rise and all in need of some type of activity. There'll also be policy recommendations for the council to adopt, and I would like for the consultant to develop a climate adaptation specific capital improvement program. Some of those things will be already in our CIP, but what I would like for the consultant to do is say, okay, if you're concerned about adapting to a changing climate, by year 2030, you should really consider implementing these type of projects. By 2040, these type. So I'd like them to lay those out with cost estimates so that we all as, citizens and community members can digest that and figure out a funding scheme. Because the bottom line is I can guarantee there will be more need than there will be funding. So there will be some selective process in terms of prioritizing and ranking those projects. So stay tuned on that. I just wanted to let you all know where we are, and I'm happy to take any questions on the plan as it moves forward.
Questions?
One question in light of some of the things you mentioned as assets to protect, especially something like 101. Those are things that involve Corte Madera and Larkspur. So do you know how this group might interact with Larkspur in the future?
Yeah, we're definitely going to make sure that the Larkspur citizens and community members and elected officials are aware of our community meetings and get their input both in writing and in the public. I think, we have a few key partnering agencies. I think the Golden Gate Bridge District will be one, Marin County, Larkspur. Those are the ones I can think of that are going to have a keen interest in this little area, Caltrans as well. So it's going to be a multi-jurisdictional effort, and we're going to need, input and involvement from all of those parties.
Yeah, I've heard that our sister organization in Larkspur, their flood control board, is eager to sometime have a joint meeting, and one of these might be a good opportunity to invite them.
I agree. That'd be a great idea to have that flood board meeting be a joint meeting. Yeah.
Is the request for proposal a public document?
It is. Yeah, it was on the website.
Okay.
It still is, I believe.
If it's not, I can provide one.
Yeah.
So Adaptation International is the company that you've selected,
Not officially.
but that's your choice.
Not officially. No, we won't know until we have those conversations with them.
Well, in following up with Nate's comments, if Larkspur is also doing climate adaptation, it would be great if both Corte Madera and Larkspur use the same consultant, because the protection that we need for Corte Madera is the same protection that Larkspur needs, which is that, the levees and the railroad right-of-way going up to Corte Madera.
It's a fine suggestion. That, of course, would be up to Larkspur. I don't have any say in who they pick for their consultant work. Yeah.
They weren't awarded grant funds through the same program we were, but perhaps they have other.
Okay, so
other
they're
things
not
set
in
aside.
on this same program.
Well, only to the extent that we want to coordinate with them and get their input,
Yeah.
but the state of California has awarded us $325,000 as the community of Corte Madera to develop this plan.
Okay.
We put in our proposal to Caltrans when we received the award that we understand that coordination will be needed because, we don't, we're very much connected to those other communities. So only to the extent that we'll be including them in the development, it wouldn't be so much them hiring their own consultant.
Okay, any other questions or comments? Thank you.
Okay.
So let's jump back to the Marina Village levy study. If you want to come up, Rachel.
I apologize for being late this morning.
That's all right. Good.
I'm just sharing a car with my teenager.
Just give me a second to shift the PowerPoint.
They usually drive faster.
Yeah, they're girls, so hopefully no. But they are distracted.
Okay.
Nice to have you back. Thank you for coming.
How long would you like me to speak?
We've set aside about 25 minutes. Yeah, and that includes question and answer. Yeah.
Good evening, everybody. My name is Rachel Kamen. I'm a hydrologist and civil engineer. Last time I spoke to you, we talked about some of the details of local flood control in the Mariners Village area. And today I'm going to talk more generally about a levy study that we've done. That Noble Consultants did. Oh, thank you. I apologize. I'm not good with mics. This evening, I'm going to give you a briefing on a levy improvement study that we did for the town of Corte Madera. And this levy is a very specific study to address this very specific levy, which protects this corner of Mariners Village. Next is, thank you, I got that. So doing this study, it presented itself in a rather unusual way. We do a lot of levee and flood protection work all over the state, but these levees are different because they have some very unique setting and design challenges, which the town of Corte Madera gets to enjoy, along with the valuable natural resources that go with. So it's a very low-lying neighborhood, Mariners Village, and it's primarily underlined by bay mud, which means that it's subject to settlement. And in fact, that bay mud loading and settlement constrain how we can improve the levees out there. So the the settlement is so great, and I'll get there, that we can't really raise the levees too much too quickly, because the more we surplus the load on them, the faster they sink. So it's really, there are two engineering questions in these designs. There's the hydraulic and flood control questions of how high should the levees be, but more fundamental and unique to this corner of the world are the geotechnical questions that go into how we can improve the levees in ways that make sense both now and in the future. So there's a lot of bay mud underneath, and we'll talk about that. Sea level rise design standards are high, and they're rising, so we know that, and it sounds like you've been getting some briefing about climate adaptation, so we'll go over a few of the numbers there. And then adjoining these levees is the Corte Madera Ecological Reserve, which is a very high-value wetland. So we are really going to be heavily constrained with regard to our ability to encroach on those wetlands. So long story short, not likely that we'll be able to push bayward at all in this situation. We're going to definitely be pushing landward if we want permits, which we'll need from all the agencies involved. And then the other thing is that if we wanted to look at alternative barrier alignments, we would need, a large project with community consensus. So this study doesn't do that. We didn't, I have thoughts about it, of course, and I'm always encouraging my clients to look and take opportunities to retreat coastally whenever they can. But that's not what we're studying here. Right now we're studying how to reconfigure the levees or improve them to provide flood protection for the community. Thank you, RJ. So when we talk about how low are we, this is a topographic map that shows you the elevations out here. So this color scale is elevation, dark blue being low, grading into high marsh. So this is subtidal, grading up into high marsh, up to about 6 feet. This is what we would consider the upland transition zone, from 6.5 feet to about 8.5 feet. And you can see that most of the properties that we're talking about are within this 7 to 9 to 10 foot range. So the homes out here are in this 7 to 10 foot range, and you can see the levees are in the 8 to 9 foot range. You can see where the town has improved levees already, and those levees are coming up to the 10 plus foot elevation, right? So what we're looking to do is kind of make comparable improvements to these more bayland levees. And they're very low-lying in nature, and so is the community behind it. And that's important because we need to recognize that these levees both constrain tidal waters coming in, but they also retain stormwater going out. So this community is essentially sitting between, tidal water coming in and stormwater going out. So the land is low lying, and this is what it looks like if you go out. There's a very beautiful marshland, very high value and high ecological value. It's a wonderful place to be close to nature in your backyard, but there are some risks. So you can see the roads protruding, and these marshes, this land is actually lower than the outboard marsh. This is a picture of the outboard marsh around the Golden Hind area, and you can see this high marsh in Pickleweed is at about 6.5 feet, whereas this marsh back here behind these homes is at 4.5, 5 feet.
That looks like the end of Echo.
It is. Echo, or maybe the one.
Harbor.
Yeah, it's the second lollipop in.
That's Harbor.
So let's talk. So I'm going to talk a little bit about each of these settings elements for you, just to provide framework. In reality, these setting elements are true in a lot of Corte Madera, so it's useful generally. And so we'll talk about bay mud and settlement. So because the bay mud is so thick, there's ongoing settlement happening out there. And when we add fill to the levee, it will increase settlement. So key to this study was the work done by Miller Pacific Engineering Group. They're the geotechnical engineers on our team. And we had civil engineers, geotechnical engineers, biologists, surveyors, and town staff all working together on this study. So this is a map that shows the neighborhood. You can see in the background the parcels of the neighborhood. But what I want you to try and focus on, though it's hard to see, are these blue lines. These blue lines indicate the depth of bay mud, and they're contour lines. So each line represents a constant depth of bay mud. So we map them like we map hillsides. We map things subsurfacely, or I should say Miller Pacific does. Something of note that's kind of interesting that I picked up on this, you see this line I called out in yellow here? That's the historic marsh front. So that's the limit of the vegetation, and beyond that used to be mud flat in the 1800s maps. Just point of reference. So we're sitting in some very low-lying land, and each one of these contours represents 10 feet of bay mud Let's see, so if we go here and we zoom in on the area of interest, I labeled some of these contours. So here the bay mud is 70 feet thick, 80 feet thick, 90, 100, 110 feet of bay mud down there. Okay?
Rachel, I was just going to comment that this entire area used to be good quality wetlands.
High quality.
It wasn't, it was bay mud out past that, but this was actually wetlands.
Oh, thank you for
Yeah,
clarifying.
we've got some nice aerial photos and old maps on that.
Yeah, I saw that was the email you sent,
Yeah.
was it? Yeah, that was neat.
Thank you. Yeah, I think, my apologies if I misspoke then. I think Miller Pacific called out that line and maybe it was edge of marsh or, I'm not sure, so.
I think that was the historic uplands where the old, or Paradise Drive was along there, and then everything on the other side of Paradise Drive was wetlands,
That
or
makes-
further out mud flats.
Makes sense.
And for those who weren't able to read the small print on the legend, those are
Oh, yeah.
borings, some that were done
Thank
prior
you.
to this study and then some that were part of the study, correct? And
yes.
then all that data went into compiling this deck.
Exactly. So there are
this map deck.
geotechnical borings that represent these dots, and Miller Pacific did some specifically, and then they consolidated all the historical data that has been collected in the area. So you can see we're in the land of essentially bottomless bay mud, and that's an important conclusion for this particular levee. It's a rather unique setting. So the reason it's unique is because the depth of the bay mud and the amount of loading determines how much and how long consolidation will happen on bay mud. And this is really the realm of geotechnical expertise, but I'll throw my hat in for the folks at Miller Pacific today. They put together this estimate of which says that over this range of bay mud thicknesses, and you can see we're probably down here in this range. We are definitely down in this range here. The calculated settlement since to date, and essentially to 2006, this is how much things have settled out there. So if you want to understand how much your storm drain system out there and how much your infrastructure has accommodated in terms of settlement thus far, that's how much we've kept, your infrastructure, your communities kept up. And then 10 years out would put us at 2016, so that's about where we are today. So the total cumulative settlement would be 4.1 feet, 4.5 feet. So here's our starting mark for settlement. And what's really important to recognize is that as bay mud thickness increases, so does the remaining settlement. So when I calculate the difference between long-term settlement and where we are in 2016, I can see that out there in those levees in the 80 to 90 foot thick range, we're looking at another 2.5 to 3 feet of settlement. That is under current conditions if we don't add fill to the top of the levees. If we add fill, it sinks faster. So that consolidation is a very important constraint on this levee. Okay, moving on. We got a lot to cover, but so we can take a look at the elevations in terms of tidal statistics. And here's the highest predicted tide in 2017 was 6.9 feet. The highest observed tide, 8.1 feet. This is very typical of what we're seeing between predictive and observed high tides. But the bottom line is we can expect tides to be regularly, routinely at 6 feet. Spring tides, 7 feet. Storm tides, 8 feet. So we have to put that in the perspective of our topography. Here's 8 feet. Here's 7 feet and 6 feet. So you can see routinely we have water surface elevations outboard of this community that are higher than this community. Okay, so these levees, no doubt they're needed. And we can look at that in terms of the way FEMA does, in terms of return period and flood frequency. So we can say every year we're going to see 7 feet, every other year 8 feet. But I put a foot on that now. And the numbers go up. So a 100-year storm right now is looking at like 9.7 feet, and a 50-year event, if we design for a 50-year horizon, 8.7 feet. So if you wanted to get to a FEMA certified levee, you'd need to get and stay above 9.7 feet, plus sea level rise. So we have to tack sea level rise on top of those consolidation rates. And if we look at state and federal guidance now, they're estimating that by 2050, we should be looking at 2 feet of sea level rise. So we're probably halfway through that number now. And similarly, at a federal level, they're suggesting that we should design for 1.5 feet of sea level rise at 2050 and 5 feet of sea level rise at 2100. Now, those are not, I said suggested, but that's what they're regulating toward. So if we're designing for the future, we have to design toward these goals. Those are huge numbers for the town of Corte Madera. And so starting to look at them in some of these most difficult corners is a good place to start. So again, we would add these. So we're looking at a need to add a lot of elevation to these levees to maintain them. And because they're sinking, we need to find a way to do it with a minimum footprint, and we're going to have to do it incrementally because that's how mud loads. Right? You put a little on, it sinks a little, you put a little on, and that's more efficient than stacking way high and watching it go. In addition, we have biological constraints, but largely we understand how to work within these very special environments of high-value wetlands. You have federally listed endangered species in the Corte Madera Ecological Reserve, and you're working within waters, federal waters and waters of the state, so you'll be in full environmental compliance. This project will have to be very heavily vetted in terms of permitting. And really where the vetting will happen is where my preference is to see you vet your alternatives in your approach, in your conceptual design with the regulators, so that as you move forward in the design process, you have their consent behind you. So with regard to the study approach in general, so that's the setting. What did? We did a bunch of field studies and mapping to determine that setting. And then once we understood the levee system, we identified the levee and we broke it up into logical segments based on the constraints that are out there. What's adjoining? What's the elevation? How much does it need to go up? And then we defined and evaluated a set of alternatives. Finally, we did some numbers. So here's the results of that study. We broke the levee up into 7 segments. This one wasn't officially part of our study, but we took it up anyway. I did largely for comparison, just to understand the differences. This levee has the ecological preserve on one side and a flood detention basin here. You can see, so there's a couple of things to look at. The endpoints of the levee are these smaller crosses, not very easy to see on a PowerPoint, my apologies. The larger lines represent cross sections where we actually surveyed a representative cross section of the levee, and that's the cross section that we did our numbers based on. What's the outside elevation, the volume, and those sorts of things. So we took representative cross sections, and then we ran the numbers for all these different scenarios. Oh, that doesn't look right. Oh, okay. So as I said previously, one of the key things that we learned about this site that's unique are the geotechnical considerations. So the settlement of the structure being the levee, is ongoing due to the underlying bay mud and its thickness. So that's something to consider going forward. The design recommendations from the geotechnical engineer really led to how we describe the scenarios. So a maximum fill depth of 3 feet in any fill event. We can only go up 3 feet in any fill event. We place the fill in 1-foot lifts, incorporating compaction and erosion control at each lift. That's a construction cost item, right? Maximum side slopes of 2-to-1 for earth and fill, slide slopes of can be greater for reinforced fill or other stabilized. And then, my apologies. And then this one was one that really sent us back to the actually sent me back to the drawing board, which is that where the fill overlies an existing levee, we can't just fill atop the levee. We actually have to excavate and backfill in 1-foot lifts because the levees that are out there are not engineered levees, and we can't fill on top of them without the levee sliding out the backside. So this is a geotechnical thing, but if we load the levee asymmetrically and it's sitting on a bay mud slip circle, essentially it's not stable on the backside. So that's another constraint to construction that came out of the geotechnical studies. So that led us to design concepts, and we looked at two types. Actually, this is not correct. This is an earthen fill. We looked at 2 earthen fill scenarios, not mechanically, that should be earthen. We looked at one in which we varied the levee top and we just topped off the levee. And one of the constraints was that the current path width right now is 10 feet, and we were trying to keep that 10-foot top width because it's a recreational use path, right? So we were trying to see if we could do that. In this scenario, we just top off the levee with fill and we let the top get smaller. So it's really the most conservative fill. We work only in uplands, so we stay out of the wetlands, and that works pretty well when we don't have to do a lot of fill. If we take a fixed width scenario where we need to maintain the 10-foot top width that's out there, we have to push not toward the ecological reserve, but back toward the detention basins, which are actually much deeper and lower than the ecological reserve, right? The marsh is at 6 to 7 feet. The stormwater basins are at 1 to 2 feet. So if we have to push back toward the storm basins, again, that turns up our volumes, our weights, and our issues. So it's, well, for a little pun, it's heavy. So we look at a fixed top width scenario, then we push back toward the detention basins or landward, and then we have to excavate and backfill this prism in order to create geotechnical stability in that scenario. Okay. We also compared mechanically stabilized fill scenarios, and those are useful because a reinforced fill, you use a geotextile fabric or a concrete blocks to retain the sides, so you can go up in a much steeper angle, which is great, less encroachment in either direction, which is great. But there are some downsides and upsides. So the TerraMesh or GeoGrid, that's a synthetic material. You essentially wrap 1-foot lifts with that. It's wonderful. You can plant in it, which is fantastic given the high value wetlands adjacent, and because we see sea level rising, we're trying to create opportunities for habitat to prograde inland. So we don't want really, ideally, the regulators don't want us to see building concrete walls or sheet pile walls on the edges of things. We have to try and make them softer, and TerraMesh along geogrids, these allow us to do that. The other, these interlocking retaining wall elements, there are many vendors that make them, but they're standard concrete block bricks, and those are fantastic because you can get very steep slopes out of them. And you can install them on one side or the other. But ecologically, they're not very good because we can't really plant within them, and it creates a hard edge for the wetland that's not seen favorably by the regulators. So this is kind of what the engineering sections looked like. Got my glasses on. So this is a geotextile fabric lap. So you can see here's the original levee cross section. We're going to put a geotextile fabric wraps in 1-foot lifts and then a gravel surface of 10-foot width. And so we developed these scenarios for each one of the 7 cross sections that you see out there, and we ran the numbers. So this is what it looks like with geotextile fabric. This is the same sort of scenario with the very vertical side with the Versalock brick. And both of these are really good alternatives for these levees. One, because we can continue to add to them. The initial foundations here create good substructure for continued raising if we use engineered fill. If we don't use engineered fill, we just kind of come back to the same problem of slippy, slidey mounds on mud. So those are really the pros and cons of, soft levee improvement, the ecological values, and the stability issues, and then these kinds of solutions, more heavily engineered solutions. And of course, we looked at a hybrid in which we use the geotextile fabric on one side, and then we return the natural slope to the ecological reserve on the other. And that's probably the best way we're going to go because, again, the bottom of the storm, where we're adjacent to the stormwater basin, the bottom of the basin is very deep. We need the vertical sides and the stability. We're going to have to cut anyway. And on the base side, we want to try and maintain that long soft edge. So this is really where we're pointing. So we looked at those scenarios for all the different cross sections. They're all in the report, all laid out if you like to look at cross sections. And we really developed a series of recommendations that were very specific to each, to different segments of the levee, because depending on where you were, different solutions made sense. So in segments 1 and 2, we're saying consider using segment blocks. If adjacent, it has, community on one side and detention basin on the other. Maybe the ecological values aren't so limiting there that we can get away with something very structural on the edge of your stormwater basin. In segments 3 and 5, 3, 4, and 5, we are suggesting terra mesh. I'll show you a picture, sorry. Because we need both stability and the ability to plant. These are low-lying levees that are between the ecological reserves and the marshes. So we need a lot. We need to be able to raise them quite a bit, and we really do need to be able to plant them if we want to get a permit in a year or so. Right? And then the other segments that require less fill, we can just top them with earth and fill. And that, of course, is going to be the most cost-effective solution. So let's see if sorry, I should have given you a picture that shows you where they are. My apologies. I must have. So you can see here's segment 1, where we're the already improved segment. We can work on the outside. These segments in here, adjacent to the pond, we think you can use the engineered stability on the backside and something softer on the wetland side. And as you go around, some of these segments over here are low enough that we can just top them off with fill, and we get in here and we end up with those hybrid solutions. So depending on where we are, we have different solutions that make engineering and economic sense. Okay, close your eyes. I'm going to go forward about 5 slides. Okay, so when we run all the numbers for all the different scenarios or all the different segments and their geometry, we ended up with this basic table of recommendations. And based on that, we got an estimate of unit volumes of materials and costs, and these are the basis for our cost estimates. We put together a very detailed cost estimate for the project, essentially applying each one of those segment scenarios and then taking the totals. And this is, well, it's almost legible. But if we go to the bottom line and start on our way back, the bottom line for our estimate for the improvement here is about $1.3 million. And we really find it quite expensive to do this mechanically stabilized earth elements. This stuff is expensive. It may be worth it here, though, because of all the compounding factors. Site preparation and field engineering, $130,000. Planning and design. Again, this doesn't include CEQA, so you're probably going to need a little bit more money there. And the total construction and earthwork cost is $230,000. So total construction, it's not that big a construction cost. It really is about geotechnical engineering and stabilization, and that's it. So the conclusions of the study are very location specific within the levees, and we have put together unit costs for each one of those types of solutions. So that should be a good a resource for the town going forward. Ultimately, in terms of recommendations, I would say this is a place where we might consider setback levees, because right now you have levees that are providing bayfront protection for your stormwater basins and then your community. So as you look at those resilient design scenarios, one thing I'm always encouraging my clients to do is shorten the length of levee that they need to maintain, and to the extent that they can, setback levees so that you're protecting your communities and your infrastructure. The further out into the bay you have to reach to do maintenance, the longer and more expensive that maintenance will be. If you're talking 50 years, 100 years. And this is a scenario where you really do need to be wise and think long-term, because if you want to maintain this infrastructure, this is a place where it will be a continuous investment. And that's all. Questions?
So are you suggesting there's a different alignment than the one you showed there that's more landward?
We've talked about a few different alignments. I've talked about a few different alignments with town staff, and the town have looked at different alignments. Last time I came in, we looked at, putting some sheet pile wall behind some of the communities back here. See if I brought one that's bigger. Sometimes I don't. So I was going to look for a bigger picture so I could show you with a bigger picture. I don't have one. Okay. In this case, you know what? This is what I'm going to do. Okay, so that's a little better. Got to stay in my circle. Okay, so in this case with these levees, if you look at the broader picture, connecting the dots out here is difficult, there's no doubt. But here's a situation where you might replace this run of levee with sheet pile at the toe of the street and then a shorter run of levee here.
Okay.
Then everything that we can do to pull back, if we can set back your levee down along the edges of the community, that would be best. And then you have the opportunity to also to maximize your freshwater, your stormwater storage in those detention basins. Right now, those detention basins, they're the top of the cup is the edge of the neighborhood, right? If we put the edge of the neighborhood up, then the top of the cup of the detention basin can get larger, and you can have more storage.
And so the town hasn't tasked you with cost estimates for basically building a new levee from scratch in that location?
Yes, and that's another reason why. So this would yes, we would look at another setback levee alignment along here. And
you haven't done that cost estimate?
No, we haven't gone any further than this. And there's broader thinking that could be done here. I guess I just want to say that before we dive into this particular construction project.
I think it's worth mentioning. So the majority of this effort was done, was it a year and a half ago? Mm-hmm. And from what we've seen in the construction bidding environment, and also it seems the permitting constraints are even getting more strict as well. We brought Rachel back to give an update on that project, but I think even those costs might need to be readjusted higher, just given what we've seen in the last 18 months. So.
Mm-hmm.
Then you're saying in the design, your spec is that everything's to 10 feet. So if all that is at 10 feet, are there any other locations on San Clemente Creek along the neighborhoods that are lower than 10 feet?
Oh, absolutely.
So if water is up to 10 feet, there's going to be flooding from elsewhere in the neighborhood?
Yes.
But Marina Village is really subject to flooding and needs to be protected because it's lower than most of the Marina Village, Mariner Cove properties.
Right.
Yeah. So
the other thing I was going to say, the idea of shortening the levee along the lines of what you talked about could make sense because I think Marin Audubon has some of the property on that levee, and I just don't know how amendable they are to bringing fill in on their levee. They get very iffy about that. But the project you're talking about would get it up to 10.
Yes.
Okay.
The estimates that we did brought the elevation up to 10 feet.
Okay. And that would protect us for the near future.
10 feet in so many increments? At what stage of the?
I believe I'm guessing, so pardon this, but I believe there's no place on that levee right now that's currently less than 7 feet. It's the lowest spots are about 7.5, 8 feet. So, and I believe we brought the surface elevation. I'd have to go back. Hold on, let me look. I apologize. It's been some time since we completed the study, so I don't have everything.
I believe the area where we put sandbags out before is just a touch over 8 feet, which is the lowest spot, I think.
Yeah, so here's, oh, sorry, it's all still zoomed in. I zoomed in, now I can't zoom out. So this shows you the lower limit of fill on the upside and downside of 7.5 and 9 feet. I'm just hoping that I have the crest elevations. No, I don't. I believe the crest elevation, it's either 10 feet or 11 feet. I apologize. I'll have to look that up for you.
The other question I have is, I had been told that some of the grasses in the detention basin would be classified as wetland vegetation, and we would have problems with that, or the way you've engineered it, we wouldn't affect those grasses or that vegetation?
Our goal is to minimize the impact on that vegetation. You can see that any place where we dip down below 7 feet in elevation, we're in wetland vegetation. And certainly within the detention bond, although it's not tidally influenced, it is most certainly all jurisdictional wetland.
It's unfortunate. We created the detention basin to protect the Marina Village and parts of Corte Madera, and now that we have wetland vegetation there, and we're limited in what we can do to maintain that.
I understand that position, but I think that it's something that you can work with, and the regulators are learning that too, which is we have to do both. Mm-hmm. And so you have to have these detention basins, and they should provide habitat. Right? They should be beautiful, ecologically robust wetlands and serve their flood purposes, as natural lands used to. So they can do both.
And so just so I understand what protection this provides, you said the lowest point on the existing levee is about 7.5 feet, and the biggest storm with the high tide that we can expect is around 8 feet, so that would overtop the lowest point. But almost any other situation, the existing levee would protect, at least in that area. So by adding 3 feet to the levee, you're still going to get flooding at 6, 7, and 8 feet that come around the levee up San Clemente Creek. So the people who live there probably won't see any difference whatsoever to how often during a year there's water in their street. I don't want people to expect there to be a big change if we spend $2 million and there's just as much water in everybody's street, basically.
I believe the proposal would protect Marina Village and keep water out of Marina Village. And it's a combination of maintaining those levees as well as the levees behind the houses on Harbor that you see at the lower part of
That's really my question, is what's the low point along San Clemente Creek on Harbor that is going to let water in? Is it at 7 feet or 8 feet?
I believe it's a little over 8 feet. I've been back there at high tide and looked at it, and the levees seem to be a little above 8 feet.
Okay.
We did I think the lowest point is over here on Golden Hine, and that was the inundation study we looked at last year, and
right.
that was at just about 8 feet.
But for this neighborhood, we're only concerned with what's on the left side of San Clemente Creek there. So.
Yeah, so, but it's something to really think about as well, because the absence of these levees and the lowest lying portions are over here. Does two things. It puts these properties at risk without doubt, but it also fills your stormwater detention basin with bay water. So these levees around here is important to public works in terms of maintaining stormwater storage capacity in flood conditions as it is to maintaining community residences. So there's a lot to think about.
And then the last question I had about the data you presented about the settlement, I think we have a lot of long-term data from the neighborhoods and the levees on how they're settling over time.
That should include it.
So the levee areas are built on marsh, so there's no fill south and north of them. Do you see them sinking at the same rate as an entire neighborhood that's at a similar bay mud depth? I just wonder if loading on top of a narrow levee does the same thing to settlement as loading over an entire neighborhood.
I don't know the answer. You'll have to ask. Yeah. But I can bring that question to the geotechnical engineers.
I'm just being hopeful and optimistic that it won't sink as fast as we think it might if you do load it.
In general, I think the majority of it is a question of how the depth of the bay mud, and if you look at the existing settlement in the neighborhood, you can probably see see settlement increase as you follow that contour downslope. Okay. The loading on the levees, interestingly enough, my experience is that once you preload, it helps a lot. So even if it's an old levee, if it's been preloaded, in other words, it's been there for 50 years, then what's underneath it is more stable than what's on either side. Okay. But that's where the asymmetrical loading comes in, and we talked about the fact that you can't just load one side because it creates a a directional force that the mud can't support.
Great, thanks, great study, thank you.
So my sense is that the board would be in agreement with trying to put a proposal together so that we would have maybe a shovel-ready project when we had some money to do something as far as flood protection for properties. Is that the sense of the board?
Absolutely, yeah.
Yeah.
Keep this moving forward. One quick thing, you mentioned the walking path and the 10-foot wide. I've walked that many times. Do we need to keep that? Can that doesn't have to be a
No, it does
path.
not. Many of the assumptions in this study there were a lot of assumptions made in terms of the geometry, and the 10-foot width was one of them. So no, it doesn't have to be, but.
Would it help the design and cost if we didn't keep that as a
Absolutely.
pathway?
Absolutely.
It
So
probably
if
would-
we can bring the top in, that helps a lot. And one thought I had is if we brought the top in, it might even be less expensive out there. Just to bring the top in, and then if you need to add width, to put some sort of boardwalk structure out there. I mean, fill on this mud is very expensive.
Because I'm sure you saw right at the basin, there's an access to a tower.
Power line?
The PG, yeah, I don't know if it's PG&E.
PG&E power poles that are out there, the
Yeah.
towers?
Yep.
Yeah.
So other than that, there's no absolute need for that top of the levee berms to be a pedestrian pathway, and it might actually add to compaction over years.
I think that if you narrowed it, it probably would decrease the cost and help in the short run. However, if something has to be done 20, 30 years from now, having a narrow path makes it more difficult for
That's right.
equipment to get out there and do that.
That's exactly the consideration that drove us to those geostabilized solutions, because if we realize that we have to keep adding 3 feet every 20 years or something like that
Yeah.
to keep pace with sea level rise and consolidation, then we need something on the bottom that's going to hold that. But before you do that, before you ask to do that, I would say really think about whether you want to hold that line there, because you can have stormwater storage behind the levees that are there 95% of the time. And so maybe that's good enough. And, then you protect the community, and it's less expensive to keep your stormwater storage not so close to the bay. My point being only that we looked at the scenarios that the town was considering at the time, but it may be worthwhile to consider retreat and different alternatives. And I think the larger study that you're planning, would be a good way to think about that.
Well,
But
the existing detention basin that's there with the pump has the ability to pump into the larger detention basin, Shorebird Marsh.
exactly.
Yeah.
So you have, that's really just a holding capacity.
Right.
Yeah, certainly something that can be analyzed further, the widths and alignments and whatnot. I think we'd probably follow the lead, though, through the climate adaptation plan.
So
This was a very broad, overall, just conceptual study, and if the town wanted to proceed, I think they would want to, do a more detailed design study.
So is that possible, RJ, to get a more detailed shovel-ready type project, which could be implemented, if there's some federal or state or AA or other money that's available to us?
Yeah, I mean, I think, again, we want to look broad first and then narrow down, and so we really want to kick off this climate plan and really get our feet wet and really understand all the priorities, and then kind of hone in on some and move forward. So as long as we're talking in that sequence, I think so. We can certainly understand the wide picture and then move forward with something.
Okay.
Yeah.
That makes sense to everybody?
Yeah, I prefer to wait for the climate study.
Yeah, I think we do have to recognize that the levees are really key to protection, not only of Marina Village, but of 101, the village, and going down to Larkspur, the Larkspur properties that are west of the railroad right-of-way levee. Thing, you agree?
I agree.
Okay. Rachel, thank you.
My pleasure.
Thank you.
Thank you.
So maybe, if you don't mind sticking around just for the next item, so we're gonna go through the Marina Village sandbag maintenance, which is kind of the short-term options for this levy we just discussed. So let me switch presentations here. So I believe it was either leading up to the last meeting or at the last meeting, there was some questions about the existing sandbags out on the Marina Village levee and how they're deteriorating. And so we spent a little time and we've made some progress on that we'd like to discuss. So in the last presentation, there was a little discussion about some of the property boundaries. And so here you have it, to the top right corner of the red line, that's state property, and California Department of Fish and Wildlife is responsible for that. And then just south of it, that little green portion, that's the portion of sandbags that are on Audubon property. The portion on their property we think is about 50 feet or so. And then on the left side, you can see the photo. That's kind of a condition as of a couple weeks ago of the sandbags. So the plastic bags are deteriorating, a lot because of the weather, but also sun and, possibly, other factors. And so the request was to try to find a way to preserve them and possibly build them up. There's also been some either settling or just the degradation of the bags has kind of reduced the height a little bit. So we recently reached out to both Audubon and California Department of Fish and Wildlife, and they did give us authorization to do a repair to those sandbags. California Department of Fish and Wildlife had requested that we just ensure that we aren't disrupting any marsh plants. So I've contacted an environmental consulting firm and trying to get them to take a look and make sure there's no marshland plants in the vicinity of where we might do some work. This is kind of the concept that we were thinking of moving forward with. To do the work, we want to clean some of that vegetation on either side. It looks like it's mostly French broom. And so once we get it delineated to make sure there's no marsh plants, we would clear some area. And then one thought is to wrap the existing sandbags in kind of a double layer of filter fabric and staple them down on the sides, and then put one row of fresh new sandbags on top. And this will get us to about the elevation when the sandbags are first installed. So yeah, these are the completed steps. We've spoken to the property owners and they've given us the okay to proceed. We'll follow up with the environmental consulting firm to help identify the marshland plants if there are any in that vicinity. Shortly after, we'll coordinate with our maintenance crew and any resources if need be to assist with the vegetation clearing. We'll bring in some sandbags and filter fabric and other material, and hopefully find a date we can perform the work prior to the heart of the wet winter season.
What's that filter fabric made out of?
So, I don't know the exact material, but they are used in a lot of environmental projects. So yeah, something to look in. It's not a plastic.
Is it biodegradable?
They will degrade over time. Yeah.
And then the sandbag material, I've used those bags before, and
right.
They have a 1-year life.
Right.
You leave them in your yard in the sun, they're done in a year.
Right.
So I don't know if you're thinking of using a different material, because it's kind of a big plastic mess out there.
Yeah, I think I think we're going to look into either some sort of burlap or double wrapping burlap, something that's more natural if possible, but also is going to be durable. So something we can continue to look into.
It's not going to be something we have to clean up later, essentially.
Right, yeah. And then I think Bob had a comment earlier via email, and then also earlier touched on it today, but in the scenario where there is a minor breach in the levee, the pumps do kick on from this detention basin and send the water over to Shorewood Marsh. So there is some capacity there to assist with any overtopping.
Questions? The only thought I might have, I think that looks like a good solution. I wonder if it might be, just as easy to take out the old sandbags, the material, leave the sand basically on the walking surface, and then put new sandbags out and wrap it with the material you're talking about.
Yeah, we looked at it. I think it would be more effort, but it's we can take another look at that. But you'd be rebuilding the whole thing from scratch, and also taking down the condition of what's there now. Whereas the hope was to create some sort of a reinforcing structure that holds it together and not have to redo the whole thing.
Okay. Looks good.
Thank you.
I just had one question. What was the cost of it? What will be the cost of it?
We hadn't drafted an estimate, but it's half a day for a biologist to come and mark out the marshlands, a small crew of our maintenance crew to do the clearing of the vegetation, and then perhaps a day with a crew, possibly 2 days to do the sandbag placement and the filter fabric reinforcement.
Give some insurance to Marina Village.
Yeah. Okay, thanks.
Okay, thank you. Where are we?
So I think we're back down here at quick update on the Marina Village storm drain improvements. Fast forward here.
Let me ask Rachel if she had any comments on that last sandbag repair thought. Okay.
Just a quick update. The project that went this summer at Harbor and Echo for the slotted drain is complete. Final project cost was $589,000, which was within the approved council budget of $630,000. And we'll be taking that notice of completion to the town council at one of the upcoming meetings.
You happy, David?
I'm happy.
David's happy. We're all happy.
My neighbors are happy.
Good.
Before we leave that item, one thing that I'd like to remind you all and all of your neighbors is that the slotted drains that are throughout Mariner Cove and Marina Village really depend upon neighborhood contributions for maintaining them. We get our street sweeper out there as often as we can. We can't always access the slotted drains because of parked cars, as well as low trees that our street sweeper can't pass through. But per the municipal code, it is the responsibility of the property owners to maintain the trees on their property and in the parkway. And that part of that maintenance is just good old get out there and rake the drains. It's really easy to do. It takes like 5 minutes. And so if you get a chance to talk to your neighbors out there or people that you know that live in the neighborhood, really help us have those slotted drains work the best they can. They're really narrow, so leaves don't tend to go into them often. But when they get wet and soggy, they can clog the slotted drains and really decrease their performance. So this is the time of year, I would say, from October through January, where really sweeping and cleaning those slotted drains is really helpful, and it takes a community to do that. So thank you.
I did notice that on 101 approaching the Golden Gate Bridge, right on the center median of the freeway, there's slotted drains and none of them work. They're all completely clogged. They don't maintain them at all. And you realize what a waste of money it is if you don't maintain them.
Maybe off agenda, but there's not just parked cars, but sometimes athletic equipment that they put on street, is there any street, city ordinance that is allowed or should not be obstructing street sweepers? Does that make sense?
I do not believe we have an ordinance that
Basketball
prevents that.
court,
Yeah,
Goals.
yeah.
Okay.
Right, so we'll move on to some updates on our pump station repairs. So this is kind of just talking about some of the it's partly routine repairs that have been made at some of the pump stations around town, as well as some failures that had to be addressed. And so this is kind of a summary of all the work that's happened over the past few months to get those up and running. Was Jamie gonna? No. Okay. All right. Sorry. Yeah, you can see San Clemente is one of our larger pump stations. We have 3 pumps there, and it's been serviced lately, but everything's up and running. High Canal, another one of our larger pump stations, 4 total pumps, and one was repaired and it's back in service. And then the others are just showing work that's been done, and one that recently had an issue was Golden Hind, and we had some metal debris caught in one of the motors, and so we're currently working to run diagnostics and get that one up and running. It's still functional, although it involves us keeping a close eye on it. So.
And then the only thing I'll add to that, RJ, is that just for the flood board's reference, this is 5 of the 10 flood control pump stations that the town maintains. We also have 19 sanitary district pump stations, and so all told, most of this infrastructure is between 40 and 20 years old, and so we're getting to the point where we're going to have to sink some bigger investments in terms of how the pumps work. And you know how well they perform. This is something that is routine. I think a couple of the maintenance guys are going to talk in a minute about things we do to prep for the winter. But one of the things we do is to really ensure that any major work that needs to be done on the pump stations is done in the summer and the fall, so that everything's at max capacity for the winter. There will be times when all of the pumps at our major pump stations are firing all at once in order to keep the town from flooding. And so we're highly dependent upon this infrastructure. So it's good to know that we've been staying on top of it and we're ready for the winter. We haven't had too many big rains yet, but 4 or 5 more months to go still.
Was everything fine with not the most recent, but whenever that big stormy event was? I'm forgetting what date that was. Not the most recent rain, but before that.
Yeah, we got about
It was
3.5 inches,
Yeah.
and it came in. It was right around Thanksgiving, I believe.
Yeah.
So that's the wettest event we've had. We did great. Everything performed well. We did have a crew come out and just do storm patrol, which we call storm patrol, just coming out and making sure everything's flowing. We don't have any flooding. The pump stations are all working, and so I think we did really well in that event. Yeah.
The one question I would have in looking at the total picture of the pumps and everything, the High Canal pump station has been so successful from the standpoint of preventing flooding on the west side of 101 that are we looking at what are the needs for the pumps at Lagoon 1 and 2 at this point, given the High Canal has taken over what they used to do?
Chair Bundy, I think the quick answer to that is that because of the infrastructure that's in place now with High Canal, we basically use the lagoons as retention and storage, and then we use the lagoons to pump into the canals, and then from the canal out to Corte Madera Creek. So that's working fine. I think you'll actually see some photos here in a minute about some of the ways we transfer the water from the lagoons to the canal. But as far as I can tell, the infrastructure is working well. I think that one thing that the guys will tell you is a lot of the work we do from the lagoons, transferring water from the lagoons to High Canal, it's done manually. So other pump stations, you know, we can do it with, you know, either programmed or we can manually change a control board. But when it comes to the lagoons, we have to go out there, and I think there's 6 or so, Vernon, 12. So there's 12 different gates. You get out there and, you know, you manually crank them, and it takes a while. You would have a really good upper body up there, Chair Bundy, if you were turning these things around. So one upgrade that we could consider doing is, and it would be a significant investment, is to go from manual to automated control on those.
I think the thought that I had in the way I've understood it is some of those pumps are superfluous at this point because of the high canal pumps. And that when those need to be replaced with maybe we don't need to replace all of them, maybe we redo it so there's automatic function on the drainage and such like that, that would be money to save on labor cost, but not have to put in the capital for the replacing all of the pumps that are there now.
Okay, that's something I don't know the immediate answer to, but I can certainly look into for you.
Well, just as we go forward and look at getting to the point of having to replace some of those. Yeah.
So let me just start us off here. So winter prep is something that, you know, takes place between, say, August and November. And I didn't work here last August, November, so I started in December, so I don't know anything about winter prep until this year. This is the first time that I've been on crew. I think RJ started in June, so this was our first time with the town of Corte Madera. I think Jamie started back in January, so I think we have our veteran here, though. Vernon Santos has been here for, I think, 21 winter preparations. So we're all learning from him. But I kind of wanted to go over, so the flood board knows, and you see the items on your agenda, all the different things we do in order to get ready for winter in the unique environment that is Corte Madera. And so I invited the guys. These are kind of 2 of our senior the maintenance workers. They've been carrying the load, making the decisions, and really helping us operate in the field. RJ and I are probably behind our desks a lot more than we'd like to be, but these guys are in the field every day, and so they see what's going on, and they stay in touch with us about what our needs are. And so I wanted you all to understand what goes into taking 3 months and really probably putting 50 to 80% of our maintenance crew's workload on really getting ready for the winter. And so we'll walk through some of those items. I think Jamie will start us off on or maybe Vernon, with adjusting our pump modes. So Vernon Santos, senior maintenance worker, why don't you come on up? Here's kind of a list of the things we're going to walk through, and we have a couple slides for each, but we have what's called high and low winter pump modes. And so it's a little counterintuitive because low mode means we're expecting rain. So we want our water all to be low. We want our lagoons to be low and our canals to be low so they have capacity to receive water. High winter mode would be when we're not expecting rain and people who live on the lagoons and recreate in the canal want to see water in the canal and not a detritus-filled mud flat. And so Vernon, talk to us a little bit about how we do that.
So what we're calling it right now is like when he's talking about the 2 levels that we keep in lagoons and canals is high winter mode and the winter mode. So when we have a prediction of no raining for more than 48 hours, what we do is we raise the levels up to the lagoons and we keep them like this until we have another notice of raining is coming up. Then we lower them 24 hours before. So that's what we do is with like local workers are doing right now in the picture on the left.
Testing. I'll try. Thank you, Vernon. Sorry.
Sure. No problem. Okay. So if you look the picture on the left side over there, what he's doing right now is changing the mode from the low wind mode to, for the high wind mode to low wind mode. Is what he's doing right now there. That's when we have a prediction of rain of 24 hours before. Is when we do this. And the other picture on the right side, what he's doing there is in Lagoon 1. That's what Peter was talking about the gates there. We have 12 gates there. That is how we control the water there. We keep it inside of the lagoon there. So this is pretty old system there. So in order to release the water from that specific lagoon, We open the inside gates and the upside side. We have a flapper gates, what we call them. When we open the inside gates, the pressure of the water going out. And that's how we keep the lagoon number 1 lower. That's how we do there. Okay. And also we check the generators, make sure everything works in case there's a power outage or whatever. Then we can have that automatically kick in, and we can still the water will be continue running there. I'm sorry, the pump stations. And also we check the fuel filters. We test the pumps every like 2 times a week, and that's all what we do. Okay. And all right.
So we'll move on.
Thank you.
As you can see in this slide, members of the board, we utilize our robo for street sweeping. Public Works typically is responsible for 4 areas here in Corte Madera. We start off with the main drags in the morning, and then when we decide that there is a large storm, our guys are actually deployed doing storm patrol. We'll report back to the lead guys to communicate with the street sweepers, so that way we can address those areas that are very concerning to us. In addition to this, we get support from Mill Valley Refuge for running on Mondays and running on Mondays in each area once a month. Another portion of this in this slide is catch basin maintenance, as well as storm drain inlets. There's over 1,000 storm drain inlets that we maintain. We actually start this in mid-October, the catch basin maintenance. That means 2 guys are utilizing the robo, and then we're clearing any catch basins from leaves or any settlement. Then we actually inspect them, and if there's some drain basins that are actually deeper, so we can't utilize the robo, so we have to use our VACCON for support for larger catch basins.
Yeah, to be clear, Chair Bundy and members of the board, you know, you probably have seen this vehicle around town. It's out almost every day, and typically you'll see it street sweeping. But if you ever see it stopped on a corner, I encourage you to pull over, or if you're walking, to take a peek and talk to the guys and see what they're doing. So there's a large vacuum that is contained on this, and it can really pull large quantities of water and debris out of the catch basins. And so most of the catch basins are clean with the Rovo. We use the VACCON, as Jamie said, when we have large ones that can't do it. But it's really an amazing, in my opinion, piece of equipment that gets all kinds of stuff done, and really, you know, empties out and cleans all of our catch basins, so that when the winter comes, maximum capacity to receive storm water is in place.
Here in this slide, you see gate maintenance. Actually, gate maintenance starts in the beginning of, or mid-April. We start clearing debris, removing barnacles, inspecting the gates. Some of the gates and bar screens, as you can see here in the slide, these are actually bar screens. This one on the right is at Black Kettle, or no, Black Kettle? Yeah, High Canal. On the far right over here is High Canal. And oh, actually, this is all High Canal. This is all High Canal.
The center one is Marina Village.
Marina Village. Thank you. Thank you, Vernon. So we inspect all gates. We actually fill out a form and then report that form back and calculate all debris removed, and then also present it in a report. We flip the bar screens as needed, and again, inspect all gates and actuators, and then simulate all actuators.
So one of the resources we offer to the community and residents are just several sandbag stations. One is here at Town Hall and Fire Station 14, and another is at Cove Park. So we just make sure those are all stocked, especially just prior to a known rain event, and so people can come and fill sandbags as needed. Another item is that does occupy these guys' time, especially in the fall when there's a lot of leaves and debris. There's many drainage easements where you have a pipe that runs underneath the road and goes from a natural ditch into a pipe, and so we're trying to make sure that it doesn't clog and fail. And so these guys, especially in the fall, spend a lot of time observing these, cleaning them out, making sure they're ready to go for the real heavy rains that occur in the heart of the winter.
And then the last thing I'll say is I'm just really impressed in my first year here with the level of work and dedication and knowledge that the maintenance crew has. They're the backbone of the Public Works Department. They put up with a lot of requests from me. And then, they get requests from everyone in town. And so it's really impressive, their ability to handle and balance a lot of needs. And so I think I'd like you all to be aware of the amount of effort they put in. And I know RJ and I are both new, and they're a great group to work with. And if you have any questions for any of us, just let us know.
Questions, thoughts, comments?
Thank you for
Yeah,
everything you do.
I think it really is a hard-working crew. Whenever I go out to check out the ebb tide flooding at high tide, whether it's the middle of the night, the crew's already out there with some signs and, their high tops on, tromping through the floodwaters. So, nice work.
One quick one for education. I've seen, I think it's the robo truck, especially on our new slotted drains, not just sweeping, but are they pressurized, putting a steam something there and it's blowing out leaves?
So yes, actually, it does have a capacity of water. It's not a lot of pressure. What that water does is actually kind of pushes the debris up, so it gives it a swirling motion, so it actually brings it into the sweeper itself.
Okay, great.
So no, it's not high pressure water where it does any kind of damage.
Oh, I wasn't worried about damage. I was impressed that it's getting into the slotted drain catch basin areas. Thank you.
Okay. Anything else?
That's all we have on the planned agenda.
Okay.
Great.
Future agenda items?
Yeah. I look forward to seeing and reading the request for proposal and the climate adaptation plan, and I'm still anxious, I'm hopeful to see it ties in past vulnerability assessments, so maybe it will address that. Because as was alluded to by Nathan, if we build up the levees at one point, we still may have flooding come through another avenue, and I was thinking that's what the vulnerability assessments may have given us insight into. Second future agenda item is maybe report from Caltrans in terms of, I've heard they were going to take some action on drainage along the highway, especially in the on-ramp to North 101. I personally experienced a very disconcerting event driving there to work one morning in the dark and went straight into a very deep puddle. So just future agenda items, report from Caltrans or from you on what Caltrans is telling the town council.
Yeah, I would say for that area and for the off-ramp.
Yep.
On the, near the consignment store, both. What's the timeline for the climate adaptation plan? I mean, what's like the next step, I guess? Is it selecting the?
Yeah, so on December 18th, we hope to award a contract
Okay.
and then probably kick off in February. And we have about 2 years to complete the project, so we have a timely use of funds issue. We're going to kind of load our schedule to do 18 months and then have the last 6 months as fallback if we need it. So I would say the bulk of the activity will be in 2019. And that'll be a lot of community meetings, gathering input. We kind of know a lot of the vulnerabilities. We need to kind of dial in where exactly some of those are. But then come 2020, we want to have a draft plan written that then can be reviewed and commented on. I'd imagine the final plan would go to council in the summer of 2020. That's the current schedule.
Okay.
And a potential agenda item, maybe you can just tell me now if this is still an issue. Golden Gate Transit was looking at using the upland portion of Shorebird Marsh as potential mitigation credits for their work in Sausalito. Is that still even a possibility?
It is. They came and spoke to council and gave an update. If I can get you the council meeting if you want to review that on video.
I can find that online.
Yeah. It's a month or two ago.
Yeah, they originally were planning on redeveloping that whole bowl
Right.
and having credits. And I think for whatever reason, they decided they would just get as much mitigation as they currently needed. So it's a much smaller project and leaves the bowl pretty much intact, still a mess.
But to Nate's point, I think it would be good in a few months' time, maybe by the summer, to get an update from Golden Gate as an agenda item. I'd like them to come and talk to the flood board about that particular project and its
And even
progress.
if it's a smaller area, that entire piece of land is essentially a mitigation bank for the town of Corte Madera to other people, including ourselves, might want to use someday. So.
Sure.
Now it's the Golden Gate Bridge District property.
Right.
So they would, have to sell that off
So they
as
own the entire
mitigation.
thing? Okay.
Yeah, if they chose to do that, I think.
Right.
The other issue, just following along on what Rachel was talking about, what we were concerned about protecting Marina villages, see if we can, get an understanding of the levees that are behind the homes on Harbor, next to San Clemente Creek. Is that the homeowner that's responsible for maintaining those? How was that set up? I think those levees really look to be pretty intact and above 8 feet. So they're in better shape than the one levee that Rachel was looking at and where we've got the sandbags. But that would be good to get that sorted out.
Okay. So to recap, I have 3 items. The Golden Gate update on the marsh restoration, Caltrans 101 off-ramp flooding, update from Caltrans, and then Harbor property ownership on the backside on San Clemente Creek. Any other suggestions?
The other issue that we talked about was possibly scheduling a joint meeting with Larkspur Flood Board.
Got it.
And,
On the climate adaptation.
Yeah, it would, their public works also in attendance, I think.
Good idea. The Twin Cities, as they've been known for a long time around here. I think anyone from the upper Midwest might challenge that term, but we do call them the Twin Cities, Larkspur, Corte Madera.
They hate our Little League hats.
Yeah.
His one old friend used to say, I think it's Corte Malarkey rather than Twin Cities. Okay, meeting adjourned?
Thank you.
Thank you, Chair Bunny.
Okay. Very good. RJ.